Good morning, student. Today in this class, student, we will be discussing the basic concepts of potential divider circuit. Potential divider. In this video, student, I will try to explain you when a current flows through any wire. Okay, if we want to find out potential at a particular point, and if we want to calculate potential difference, okay, how to calculate it? Because this basic is required, student, in the topic potentiometer. Potentiometer is a multi-purpose device. Okay, it can be used to compare EMF, it can be used to measure the EMF of a cell, it can be used to measure the internal resistance of a cell. Many things are there. Okay, to have the basic concept of this instrument, we should know, student, potential divider. Okay, so first I am explaining you potential divider circuit. Suppose, student, we have a combination of resistance like this. Now here, student, I am connecting a battery. This student I am taking is 15 volt. This cell is of battery 15 volt. Okay, student. Now suppose, student, this is having resistor 2 ohm. This is 3 ohm. I should take a number which can easily divide, student, so that the mathematics will become easier. Okay, student. So 2 ohm, 3 ohm, 5, and say, student, this I am taking 5 ohm, and this battery I am changing, student, 20 volt. Okay, these are the resistors which are connected here. Now, student, this circuit already you know it. How much current will flow through this circuit? V upon R. Total R is, student, 10. So 2 ampere current is flowing, student. Okay, 2 ampere. Now, student, you see, when current flows through this resistor, there is a potential drop or there is a potential difference across this, say V1. Across this, potential difference is V2. Across this, V3. As the current crosses this resistor, there is a potential drop takes place, and that drop is IR. Now current is 2 ampere. Okay, student. So if I use this formula, V is equal to IR, how much is the potential difference across this resistor? Say this I am naming it as R1, R2, R3. Okay. So by the Ohm's law, student, I will get V1 as IR1, and this, in this calculation, I is 2 and R is also 2, 4 volt. So student, a potential drop of 4 volt, or you can say potential difference across these 2 points is 4. That is the meaning, student. Okay. Now further, how much is the potential difference across this? It is IR2, student. Okay, I is same series circuit, R is 6 volt. This is 4 volt, 6 volt, and here is, student, V3. This already you know it, student. I want to come to a concept by explaining you this. IR3, 2 into 5. This is 10 volt. Okay, student. 4, 6, 10. Total you see 20. Now, student, see. Nodal analysis. I am considering this as a 0, so this will be 20. This is 20. This is at 20 volt, student. Now the question is, how much is the potential here? This point. The potential drop of 4 has taken place here. So this means the potential here will be, student, 16. This you have to understand, student. Means at this point the potential is 16. How I got it? 20 is here, potential difference 20 minus 16, 4, or I can say a drop of 4 volt has taken place as the current passes. So here the potential is 16. Similarly, student, if I want to find out potential at this point, now see, potential drop, potential difference across 3 is how much? Across 3 ohm, 6 volt. 6 volt drop has taken place, student. So here it is 16, so here the potential will be 10. 10 volt student. Here again the current is passing. How much is the potential drop? 10. Now see it is 0. Now see student, I got the potential at particular point. Here 20, here 16, here 10, here 0. So this is a potential divider circuit student. Okay. Now student, let's see another formula of potential divider circuit. Student, here V1, how much I got V1? Again I am writing IR1. I is 2, R is 2, 4 volt. Okay student, I am getting 4 volt. Now student, by another way, I can find out V1 like this. See, R1 upon R1 plus R2 plus R3 into total V. Just apply this formula student. R1 is how much? 2. Total 2 plus 5, 10. Okay student? Into 20. See student, again I am getting 4. This is the basic formula you have to remember to, to find out student potential difference. Similarly, I can find out V2 by this formula student. See. How will you find out V2? This is the potential divider formula. R2 upon total R into total V student. So how much is R2 student? 3. Total R is 10. You see 3 plus 2 5 plus 5 10 into 20. See student, again I am getting 6 volt. And if you do by formula I into R, I is 2, R is 3, 6, again 6. So this is how the potential divider formula works student. This formula is required in many cases student. Here see I don't require current for this formula to measure. Okay student. Now student, what I am doing is now I am taking a wire having uniform cross section and composition. Say wire made of alloy. I am taking an alloy having uniform cross section and material. See, this is that alloy wire student. This is. Okay student, this is that wire. Say suppose I am taking the length of this wire to be 1 meter. And student, suppose I am assuming the resistance of this wire to be R. Resistance to be R. Okay, total resistance R. Now student, I am connecting a battery here. This is not a conductor. This is not a conductor. This is short circuit. Okay, it is a alloy made of wire. Okay, it is a wire which is made of alloy. This battery student, I am taking say 10 volt. Okay student. Now student, by nodal analysis, this is 0 and this is, if I take 0, this will be 10. This is 10. Here the potential is 10. Here potential is 0. Okay student. Now student, what I am doing is I am taking any point here and say student, this point is at distance 0.7 meter. As I told you, total length is 1 meter. This is 0.7 meter. This is 0.3 meter. Okay student. Now student, I want to know the potential exactly at this point, means at a distance of 0.7 here, say here A. How I will find out? Okay. Now student, this part and this can be considered equivalent to 2 resistance. You see. Now if you know the formula of resistance student, it is rho L upon A. If rho and A are constant, R is proportional to L. Okay. Now student, since the total length resistance is R, so this much part resistance I can take it 0.7 R. And this part resistance I can take it 0.3 R. See, total is R. Okay. Because R is proportional to L. So for a length of 0.7 meter, the resistance is 0.7 R. So this resistance is 0.7 R and this is 0.3 R. Now student, I have to find out potential difference across this. So just now I told you the formula, student. What is the formula? I have to take R means 0.7 R upon total R I have to take. So total resistance I have already taken R into, student, the total voltage 10. Student, I got V1 as 7. This means, student, potential difference across this is 7 volt. Similarly, you can find out potential difference across this, student, V2. How? Same formula. Now the resistance is 0.3 R upon total resistance into 10. See, student, 3 volt. Now, student, one more thing. The potential difference between these 2 points is 7 volt. Okay. This means, student, potential here is 3 volt. This you have to understand. See, 10 minus 3 is 7. So generally, student, they commit mistake. What they do is they write it 7 here. No. Potential here is 3. The difference is 7, which can be found out by potential divider formula. This is the basic, student, you have to understand. Now I can find out at any point the potential, you see. Now, student, suppose I take a point at a distance 0.2 meter. Okay. How much is the potential here? How to find out? Now see, 0.2 meter means resistance is 0.2 R, as I have assumed. Okay. Now potential divider formula. R1 upon total R is R into 10. Students, see, it is 2 volt. So potential difference is 2 volt means here the potential is 8. Like this, student, you can find out potential at any point. Now I am again redrawing the circuit, student. This is that wire, student. Okay, whose length was 1 meter. And total resistance was R. And just now I have seen at a distance of 0.7 meter, the potential here was 3 volt and the difference was 7. Okay, here I am writing the data. 0.7 meter, the potential difference was 7 volt, but the potential at this point was 3 volt. Just now we have calculated, student. Now, student, if you see this wire, it is of length 1 meter. It is of length 1 meter, student. 1 meter means 100 centimeter. Means 100 centimeter length. The voltage drop is 10. See, 10 drop. From here 10, it is 0. So 1 centimeter, student. How much is the voltage drop? It is 10 upon 100. .1 volt, student. So, student, per centimeter voltage drop is 0.10. So 100 centimeter, it is 10 volt. So this is a very important quantity, student. Voltage drop per unit length. It is known as potential gradient. Now see what I have found out, student. Per centimeter, the voltage drop is 0.1. Means if I take any 2 points, the distance is 1 centimeter. The potential difference will be 0.1. That is the meaning, student. If I take this. So 1 centimeter difference means for a 2 points having 1 centimeter length, okay, the potential difference will be 0.1 volt. Will be 1 volt, student. This is the meaning. Now, student, If I connect here another circuit, see. Now suppose student in this position, here the potential potential is 3 student, just now I have explained you. This length is 0.7 meter. Here the potential is 3 volt and the difference is 7 volt. Okay. Now suppose in this case galvanometer is showing 0 deflection. So 0 means student across the galvanometer potential difference is 0. So here it is 3, here also 3 should be there. Okay student. Now when nodal analysis, this I have considered 0, this is 10, this is 10, this is also 10. So here potential is 10, here it is 3. This is null deflection I am talking about. Okay. This means student, this potential difference across the battery is 7. This means EMF of this battery is 7. This is the meaning student. So indirectly student, by this arrangement I can find out EMF of this battery, you see, by finding the null point. So basically student, this part of the instrument, this wire, it is known as potentiometer. Potentiometer is only this much part, and by the help of this I can find out student unknown EMF. So this student I will continue in the next lecture with more detail. So today basically my aim was to explain you how to find out potential at any point and potential difference by the help of potential divider formula. Thank you student.